Hello, today we're going to talk about problem 3.29. And in this problem, we're given a set of different molecules and we're asked if they're either constitutional isomers or stereoisomers. Just to remind you what they are, constitutional isomers are compounds that have the same molecular formula and differ only in connectivity, just like these two molecules, where the methyl group is placed at a different position on the butane here. It's in the second position here, while it's placed in the first position here, making it now pentane. Stereoisomers are isomeric molecules that have the same molecular formula um, and sequence of bonded atoms, but that differ only in the three-dimensional orientations of their atoms in space. And here I showed you this image of a cyclohexane where the methyl groups are attached differently. Here it's attached in the equatorial position and in the axial position, whereas in the second one they're both attached in the equatorial position. 1,3 equatorial, 1,3 equatorial, and axial. Alright. So the first problem asked gives you a 2,2-dimethylpentane, a 2,2-dimethylhexane, and a 2,3-dimethylpentane. What I did for this problem was just write the molecular structure of it out. So for 2,2-dimethylpentane, you have 7 carbons, 18 hydrogens. For 2,2-dimethylhexane, you have 8 carbons and 18 hydrogens. And for 2,3-dimethylpentane, you have 7 carbons and 16 hydrogens. So who do you think is the either constitutional isomers of each other or stereoisomers? 2,2-dimethylpentane and 2,3-dimethylpentane are the constitutional isomers because they only differ in connectivity. Next, we have 2-methylpentane, 2-methylpentane, and 3-methylpentane. Now, which of the three do you think are the constitutional isomers or stereoisomers? 2-methylpentane and 2-methylpentane are the exact same molecule, and all three of them are constitutional isomers because they only differ in the connectivity between the methane in the second position and in the third position. So these two are identical, while all three are constitutional isomers. For the next problem, we have pentane, cyclopentane, and 1,1-dimethylcyclopropane. The molecular formula for pentane is 5 carbons, 18 hydrogens. For cyclopentane, it is 5 carbons and 10 hydrogens. And for 1,1-dimethylcyclopropane, it's 5 carbons and 10 hydrogens. Which do you think are either constitutional isomers or stereoisomers of each other? For C, cyclopentane and 1,1-dimethylcyclopropane are constitutional isomers because they have the same molecular structure of 5 carbons and 10 hydrogens. 5 carbons and 10 hydrogens. This is a different structure compared to the rest. For letter D, we have cis 1,2-dimethylcyclobutane, trans 1,3-dimethylcyclobutane, and trans 1,2-dimethylcyclobutane. Now, which do you think are the constitutional isomers or either stereoisomers of each other? Cis 1,2-dimethylcyclobutane and trans 1,2-dimethylcyclobutane